Hi all. Very happy evening to each and every one who is watching me live. I hope there are no audio issues, no tech issues. Another very important chapter which we are going to discuss. We will spend some good amount of time in knowing the complete details. I hope there are no audio issues. I hope there are no audio issues. If anybody is watching live, kindly reply. And there are no buffering issues. No buffering issues. Extremely important topic. We will spend a lot of time in understanding the variety of questions that are coming from binomial theorem as well as multinomial theorem. If anybody is live right now, kindly reply in case if you are facing any issues. Let me also check it out in my mobile. The variety of questions. Right. So there are no issues. Audio is proper. Now, if you see here, binomial and multinomial theorem. Binomial, there were some good number of questions which came from binomial theorem as well as multinomial theorem. Totally close to about, to discuss these entire concepts, we require close to 4 sessions in detail. We will discuss completely. 4 sessions which we will take it up to discuss all the problems from multinomial and binomial related things. Now, what are we going to discuss today? Now, how the kind of questions will come. Today's class, binomial and multinomial theorem. In this class, what we will do is, like inequalities, we will divide the class into conceptual, funda class, 1 class, practice problems, then last it is cat level questions. Funda problems. Today's session number 1, 4 sessions we will discuss. In session number 1, what I will do is, I will discuss the fundamentals. Session number 1, I will discuss fundamentals. I'll discuss fundamentals. Then session 2 and 3. Session 2, 3, we will do a lot of practice problems. We'll do a lot of practice problems. And in session number 4, we will do cat level problems so that you can start from basics and can get into the advanced level, cat level problems. Cat level problems which we will discuss. Session 1, fundamental, session 2 and 3, practice level problems, and session number 4, cat level problems. Now tomorrow's class, like today's class, tomorrow's class schedule also I will give it right now. Tomorrow's class schedule. We will take 3 to 4 sessions. 1 p.m. session 1. Session 1. Then next session 4 p.m. session 2. Then next session 7 p.m. session 3. 3 sessions I will take tomorrow to finish off these binomial and multinomial theorem. By tomorrow evening, most likely binomial and multinomial theorem will be there. So let us not waste any time. Let us get into session number 1, fundamentals. Session number 1, fundamentals. Now, first of all, in this class, we will understand what do you mean by binomial theorem. There are various kinds of problems that will be asked. He might ask a question based on how to find the generic term, how to find the generic term, how to find the independent term, how to find the coefficient of x power r, coefficient of x power r, some property based questions, some property based questions. Sum of the coefficients, Once you understand some of the coefficients, we will also discuss some of the even coefficients, and some of the odd coefficients. Then we will discuss miscellaneous level problems. Miscellaneous are the kinds of problems which does not come in session 1, 2, 3, 4 and 5. This is with respect to binomial theorem. In multinomial we will discuss, okay. In binomial theorem, apart from sixth type, there are also some question. How many terms, integral terms are there? Rational terms are there? Irrational terms are there? Irrational terms are there in the expansion. Integral terms, rational terms and irrational terms. Session 4, we will target about close to 35 to 45 questions with fundamentals, so that not a single question you will miss it out in binomial expansion. These are the kinds of questions that will come. But today, first class, I will only concentrate on fundamentals. In the next classes, we will take up practice problems and cat level problems. Now, let us discuss what do you mean by a binomial. What do you mean by a binomial? Now, see here. The first definition of a binomial function. Binomial. Bi it is nothing but 2. Nominal. Binomial. It is a polynomial. It is a polynomial with 2 terms. It is a polynomial with 2 terms. Suppose if you see x plus 2y. X plus 2y. This is one term and it is another term. How many terms are there in this expansion? 2 terms are there in this expansion. If a polynomial has got 2 terms, then that polynomial is called binomial. If a polynomial has got 3 terms, it is called trinomial. Tri is 3. Bi means 2. A polynomial with 2 terms. A polynomial with 2 terms, it is called binomial. I hope the definition it is clear. See here, there is one term, there is another term. One term and another term. There is a one term and another term. If there is a polynomial with 2 terms, then it is called a binomial. The power can be 1, power can be 2, power can be 3, power can be 4, power can be 5, and so on and so forth. Listen carefully. I hope the definition of a polynomial, it is clear to you. Now, listen carefully. Listen very carefully. Suppose if I take x plus y, let me give some natural number powers to x plus y. X plus y power 1 is x plus y. X plus y whole square. X plus y whole square is x square plus 2xy plus y square. Plus y square. Now if you observe carefully, here the power is 1. How many terms are there? 2 terms are there. Here the power is 2. How many terms are there? 3 terms are there. Suppose if the power is 3, how many terms are there? There will be 4 terms. 3x square y plus 3xy square plus y cube. That means if the power is n, how many terms will be there? N plus 1 terms will be there in the expansion. Please write down this one. In x plus y power n, if the power is n, totally how many terms will be there? N plus 1 terms will be there in the expansion. If the power is 4, I will get 5 terms. If the power is 5, I will get 6 terms. If the power is n, how many terms I will get? N plus 1 terms I will get. If power is n, I will get n plus 1. Sir, the question arises. If the power is n, why am I getting n plus 1 terms? Why it is 1 more than the power? Why it is 1 more than the power? Now listen carefully. X plus y whole square. x plus y whole square. Power is 2. Power is 2. Now, listen carefully, sir. Now, very importantly, listen. How many powers? What is the power of x plus y? It is 2. From 2, do not select any power of y. 2c0 means from the power of 2, do not select any power of y. So I am not selecting any power of y. So it is y power 0. From 2, select one power of y. It is y power 1. From 2, select two powers of y. So it is y square. It is y square. It is y square. Now if you see here, so from 2 I am not selecting any power of y. If I am not selecting any power of y, now if you see here, not selecting, here one important property it is there. NCR equivalent to NCN minus R. NCR equivalent to NCN minus R. Now listen carefully. There are 5 students sitting in a class. There are 5 students sitting in a class. Out of 5 students, I decided to select 2 students. There are 5 students sitting in front of me. I am selecting 2 students. Now listen carefully. Out of 5, I am selecting 2 students. Out of 5, if I am selecting 2 students, that means I am rejecting remaining 3 students. I am telling to 5 students, yes, I want you for the competition. I want you for the competition. Out of 5, I am selecting 2. Out of 5, if I am selecting 2, that means I am rejecting remaining 3. Yes or no? Selecting 2 is nothing but rejecting 3. Rejecting 3 is also one way of telling them, I don't need you. I need you. I don't need you. If I am selecting 2, that means I am rejecting 3. If I am selecting 2, that means I am rejecting 3. Or in other words, if I am rejecting 3, I am selecting 2. If I am selecting 3, I am rejecting 2. All are same. Out of n, if I am selecting R, out of n, if I am selecting R, that means I am rejecting n minus R. Are you all with me? Out of n, if I am selecting n minus R, that means I am rejecting R. That is the reason NCR equivalent to NCN minus R. Out of n, if I am selecting R, that means I am rejecting n minus R. Out of 5, if I am selecting 2, that means I am rejecting 3. If I am selecting 3, that means I am rejecting 2. Are you all with me? Are you all with me? That means out of 2, I am not selecting any power of 5. That means I am selecting all the powers of x. From 2, I am selecting one power of 5. That means remaining one power of x is rejected. Out of 2, I am selecting all powers of y. That means I am not selecting any powers of x. Are you all with me? So if you observe here, if it is 2, out of 2, I am not selecting any. Out of 2, I am selecting 1. Out of 2, I am selecting 2. Out of 2, I am selecting 2. Suppose if power is 4. If power is 4. Out of 4, I am not selecting any. Out of 4, I am selecting 1. Out of 4, I am selecting 2. Out of 4, I am selecting 3. Out of 4, I am selecting all 4. How many terms will be there? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So out of n, think logically. Out of n, I am not selecting any. NC0, one term will be there. Out of n, I am selecting 1. Second term will be there. Like that, out of n, I am selecting all n. It is starting from selecting none to selecting n. From 0 to n. From 0 to 2, how many terms are there? 0, 1, 2, 3. From 0 to 3, how many terms are there? 4. From 0 to n, how many terms are there? N plus 1. This is the reason behind. If the power is n, how many terms will be there in the expansion? N plus 1 terms will be there in the expansion. N plus 1 will be there in the expansion. You will not remember any formulae. You will remember like this: x plus y whole square. X plus y whole square. Out of 2, you are not selecting any power of y power 0. Out of 2, you are selecting 1 power of y. Out of 2, you are selecting 1 power of 2 powers of 2. Remember here another important point. The sum should be equivalent to the power. The sum should be equivalent to the power. Sum should be equivalent to the power. I hope this slide is very, very clear to you. This slide is very clear to you. Only if you understand it, then you will be able to solve a lot of problems with absolute conviction. X plus y power 3. X plus y power 3. Out of 3, I am not selecting any power of y. Out of 3, I am selecting only 1 power of y. Out of 3, I am selecting 2 powers of y. Out of 3, I am selecting all powers of y. If I am not selecting any y power 0, that means I am selecting all the powers of x cube. I am selecting 1 power of 5. That means the remaining x square will come. I am selecting 2 powers of y. Remaining x power 1 will come. I am selecting y power 3. Remaining x power 0 will come. I hope the expansion, it is very, very clear to you. I hope the idea, it is clear. If the power is k, how many terms I will get? K plus 1 terms I will get. K plus 1 terms I will get. So we will write down some important key points. In x plus y power n, in x plus y power n, what is the first important key point? N plus 1 terms will be there. N plus 1 terms will be there. N plus 1 term will be there. I hope it is there. First term, it is starting with 0. Second term, it is starting with 1. Third term, it is starting with 2. Fourth term, it is starting with 3. Are you all with me? That means if it is x plus y power n, first I will not select any power of 0, y power 0, x power n. I will select only 1 power of y. It is x power n minus 1. I will select 2 powers of y, x power n minus 2. And so on up to. I will select r powers of y power r, x power n minus r. I will select all n powers of n, y power n, x power 0. I hope this binomial expansion, it is very, very clear to you. I hope this binomial expansion is very much clear to you. Any doubts are there? Kindly ask me in the live chat in case if you got any doubts. Any doubts are there, please ask me. And another important point. Sum of the powers 0 plus n, because total n I need to distribute. If I am not selecting any power of 5, power of n should be selected. 1 I selected for y power 1. Is right, remaining x will be power. Sum of the powers is always equivalent to n. Sum of the powers is always equivalent to n. Sum of the powers is always equivalent to n. Are you all with me? Second key point. I hope it is clear. Now if you see here, another very important key point. Suppose x plus y power 3 it is there. X power y power 3 is there. A term can be written as k into x power a y power b. X power a, y power b. Can I say sum should be is equivalent to 3? A plus B is equivalent to 3. Can power take 0? Yes. A greater than or equivalent to 0. Can B take 0? Yes. B greater than or equivalent to 0. How to determine the positive integral solution? Add 1, add 1. 3 plus 2, 5. If 5 balls are there in a number line, how many gaps are there? 4. Select any one. 4C1. How many number of terms are there? It is 4C1. This is a very, very important concept. I think I will explain in a new slide. New slide. Listen carefully, sir. Find the number of terms. Find the number of terms in the below expansion. Find the number of terms in the expansions. Find the number of terms in the expansion. Now listen carefully. Find the number of terms in the expansion. 3 problems. If you understand, it's enough. Suppose first one. Easy one. A plus B power 8. A plus B power 8. There will be some coefficient 8CR. We don't need it. K into A power X into B power Y. Can I say that I will not select any power of 5? Yes, that is possible. Sum of the powers X plus Y is equivalent to 8. X is greater than or equivalent to 0. Y is greater than or equivalent to 0. Y is greater than or equivalent to 0. Suppose if the question is P plus Q equivalent to 4. P comma Q greater than or equivalent to 1. P plus Q equivalent to 4. P comma Q greater than or equivalent to 1. 4 means there are 4 balls. How many gaps are there? 3 gaps are there. If 4 balls are there in a number line, how many gaps will be there? 3. Out of 3, select any one gap. If I select this, 1 plus 3. If I select this, 2 plus 2. If I select this, 3 plus 1. Out of 3 gaps, select any one. So 3C1. 3 solutions are there for this equation. 1 plus 3, 2 plus 2 and 3 plus 1. Am I right? P plus Q equivalent to 4. P and Q minimum value it is 1. So 4 means I represent it as 4 balls. How many gaps are there? 3 gaps are there. If 3 gaps are there, if I select this gap, 1 plus 3 it is one solution. If I select this gap, 2 plus 2 another solution. If I select this gap, 3 plus 1 another solution. Out of 4 balls kept in a line, there are 3 gaps are there. Out of 3 gaps, select any one gap. Out of 3 gaps, select any one gap. Answer will be 3. I hope the idea it is clear. First we will do this example. P plus Q plus R equivalent to 12. PQR greater than or equivalent to 1. PQR greater than or equivalent to 1. If 12 balls are there in a line, how many gaps will be there? 11. If 2 variables are there, 1 cut it is required. If 3 variables are there, 2 cuts are required. 11 into 10 by 2. What will be the answer? 55. How many integral solutions, positive integral solutions are there for this question? P plus Q plus R equivalent to 12. Answer is 55. Answer is 55. Here it is starting from 1. Here also it is starting from 1. But the powers can be 0. But the powers can be 0. So what you do is add 1 to it, add 1 to it. 8 plus 2, 10. If 10 balls are there in a line, there will be how many gaps? 9 gaps are there. 2 variables, 1 cut. 9C1. What will be the answer? 9. How many terms are there in this expansion? Total 9 terms are there. It is a binomial. Slowly I will increase the number of variables. I hope the idea it is clear. A plus B power 8. The general term is given by K into A power X into B power Y. We are finding the number of terms, so K is of no relevance. Powers can be 0, so x plus y equivalent to 8. It can be 0, so x is greater than or equivalent to 0, y is greater than or equivalent to 0. Both of them should start from 1. So 1 and 1 are added. 8 plus 2, it is 10. So 10 balls are there. How many gaps are there? 9. 9C1, it is 9. 9C1, it is 9. Similarly, second question. A plus B plus C. Power 12. How many terms are there in this expansion? The generic term will be k into a power x into b power y into c power z. Sum of the powers should be equivalent to the power in the question x plus y plus z is equivalent to 12. Powers can take 0, x greater than or equivalent to 0, y greater than or equivalent to 0, z greater than or equivalent to 0. We know how to solve when they are starting with 1. So 1, 1, 1. 12 plus 3, 15. If 15 balls are there on a line, how many gaps will be there? 14. 2 variables, 1 cut. 3 variables, 2 cuts. Totally, how many terms will be there in this expansion? 14C2. 14 into 13 by 2. Answer for this question is 91. Answer for this question is 91. I hope the idea it is clear. You don't need to solve all this. This question can be solved it in 5 to 10 seconds if you understand the logic. How many variables are there? 3 variables. 12 plus 3, 15. If 15 balls are there, how many gaps are there? 14. So 3 variables, 2 cuts. 14C2. If the question is A1 plus A2 and so on up to A8, power 20. A1 plus A2 and so on up to A8, power 20. What will be the number of distinct terms? 20 plus 8, 28. 28 variables are there. So 27 gaps will be there. 3 variables, 2 cuts. 8 variables, 7 cuts. Answer is 27C7. Answer is 27C7. If the next question is A1 plus A2 and so on up to A20, power 40. What will be the number of terms? 40 plus 20, 60. 60 means there are 59 gaps, 20 variables, 19 cuts. 15, 9, C, 19. Very beautifully from the fundamentals, we can solve the problems. I hope the idea it is clear. Any doubts are there? Kindly mention. Very interesting way to look at it. In our advanced session, we will also see AB plus BC plus AC power 8. We will also see how many terms A plus B minus C power 8. Advanced level session. 3 more sessions. I will do it fundamental class where I am going to discuss a lot of fundamentals. I hope the idea it is clear. Find the number of terms. Based upon this, there was a CAT question. Find the number of distinct terms in A plus B plus C power 20. What will be the answer for this question? A plus B plus C power 20. 20 plus 3, 23 balls. 23 balls means 22 gaps. 3 variables means 2 cuts. Answer is 22C2. Answer is 22C2. I hope the idea it is clear. Now another very, very important concepts. One by one we will discuss. One by one we will discuss. First important property of a binomial coefficient. NC0 equivalent to NCN equivalent to 1. Please do not mug it up. I will tell you in a very logical way. NC0 equivalent to NCN equivalent to 1. Why it is NC0 equivalent to NCN equivalent to 1? There are 10 students sitting in front of me. I said all the students who got more than 98 percentile in CAT examination, please go to the next class. Please go to the next class. I entered into the class and I made an announcement. None of them got greater than the required percentile. That means I entered into the class and I made an announcement. None of them fit the criteria and I exited the class. In how many ways can I reject all the students sitting in the class? There is only one way. There is only one way. NC0 equivalent to NCN equivalent to 1. A teacher entered into the class. Suddenly, he was about to start a topic. The student said, "Sir, you came to 9th class. You have to go to 10th class." So immediately he left the class. Out of N, I am not selecting any. I am not selecting any. Suppose there is a question of 4 options. There is a question of 4 options, right? You decide, you did not attempted this question. In how many ways you will not attempt a question? Only one way, right? If you attempt a question, then there are 4 ways. Either you can click option A, or you can click option B, you can click option C, you can click option D. Attempting a question, you can do it in any 4 ways. You read the question, you did not understood the head and tail of the question, you move to the next question. Out of N, you are not selecting any. You are not selecting any. In how many ways can you do it? In how many ways can you do it? Only one way. Suppose I went into a CAT examination. I wanted to know what will be the lowest percentile a student will get if he does not attempt any paper in the examination. So, entire 3 hours I was just sitting, I was looking at the question, I did not attempt any question. At the end, I clicked on the submit button and I left the examination hall. Did I attempt the paper? Yes, by clicking on the submit button. Did I attempted any questions in the paper? No. In how many ways I can do it? Went there, clicked the submit button and came back. Out of N, I am not selecting any. How many ways I can do it? One way. If I am not selecting any, that means I am rejecting all. Not selecting any is nothing but rejecting all. So in how many ways? Suppose there are 10 people sitting in front of you, right? ANIL NAIR want to recruit a faculty. He entered, he conducted examination and none of them cleared the cutoff. I said I am rejecting you all. Selecting none is equivalent to rejecting all. Selecting none. Selecting none is equivalent to rejecting all. Selecting none is equivalent to rejecting all. So in only one way that you can do it. In only one way that you can do it. That is the reason answer it is 1. I hope the first concept is very, very clear to you. Any doubts are there? Any doubts kindly mention. Selecting none is equivalent to rejecting all. That is the reason NC0 is equivalent to NCN equivalent to 1. First property it is clear. Second property. NC1 is equivalent to NCN minus 1. Forget about the answer. Suppose there are 4 kids in front of you. There are 4 kids in front of you. You want to select one. You want to select one. In how many ways you can do it? You came here. Let us name these people as A, B, C, D. There are 4 people in front of you. You need to select one. Either I can select A, or I can select B, or I can select C, or I can select D. Yes or no? That means if 4 people are there, either I can select A, or I can select B, or I can select C, or I can select D. A or B or C or D. You are at, for example, I am at Hyderabad, Banjara Hills. I need to go to a place, Himayat Nagar, right? A to B. There are one way to go by metro, one way to go by bus, another way to go by car, another way to go by walk. There are 4 ways. One is to go by metro, another is to go by bus, another is to go by car, another is to go by walk. In how many ways I can go? Either I can go by metro, either I can go by metro, or I can go by bus, or I can go by car, or I can go by walk. How many ways are there? 4 ways. One way, second way, third way, fourth way. I have a choice. I have a choice to make. I can choose any one out of these 4 ways. Here also I have a choice. Either this, or this, or this, or this. So out of n, I can choose any one. That can be done in n ways. That can be done in n ways. Out of there are 4 choices for me. Either metro, or bus, or car, or walk. Either A, or B, or C, or D. So out of n, I am selecting one. That one could be the first person, or second person, or third person, or it could be an nth person, or it could be an nth person. So NC1 is equivalent to, if I am selecting one out of 4 people, I am selecting one. If I am selecting one, that means I am rejecting 3. Are you all with me? Out of 4, if I am selecting one, that means I am rejecting 3. That is the reason. Here it is clear to you. Third point proof for the third one also will come. Out of n, if I am selecting k, that means I am rejecting n minus k. Reverse is also true. If I am selecting n minus k, that means I am rejecting k. Selecting few is equivalent to rejecting other few. Selecting out of 8 people, if I am selecting 3, that means I am rejecting 5. That means if I am selecting 5, I am rejecting 3. That is the reason. Third proof also came into picture. NCR equivalent to NCN minus R. I hope the third one it is also clear to you. Not selecting any is rejecting all. Selecting one, it can be done in 1 out of n number of ways. Selecting 1, it is rejecting n minus 1. Selecting a k, it is rejecting n minus k. Selecting k, it is rejecting n minus k. I hope these are clear. These are very, very important property. I will come to it when we are discussing some integral solution. Fourth property, 2 power n equivalent to C0 plus C1. C0, okay, now I will write down here. X plus y power n, x plus y power 3. For example, out of 3, I am not selecting any y power 0. Out of 3, I am selecting y power 1. Out of 3, it is y power 2. Out of 3, I am selecting y power 3. That means x power 0, x power 1, x power 2, and x power 3. X power 3. Now if you see here, sum of the coefficients. How to find out the sum of the coefficients? What is, D is a coefficient, D is a coefficient, D is a coefficient, and it is a coefficient. So what is the sum of the coefficients? Sum of the coefficients can be obtained by making 1 in place of every variable. 1. What is 1 plus 1? 2. 2 cube, it is 8. So 3C0 plus 3C1 plus 3C2 plus 3C3. Out of 3, I am selecting none. It can be done in one way. That means rejecting 3. It is also 1. Out of 3, I am selecting 1. It can be done in 3 ways. Out of 3, I am selecting 2. I am rejecting 3. So 3 plus 3 plus 1, which is equivalent to 8. Which is equivalent to 8. How to find out the sum of the coefficients? Sum of the coefficients can be found out. Sum of the coefficients can be found out by placing 1 in place of every variable. By placing 1 in for every variable. by placing 1 for every variable, you will get the sum of the coefficient. Not only for power 3, power 4, right? By placing 1, wherever variable is there. Suppose if it is 2x plus 3y power 5, wherever variable is there, substitute 1 in place of variable to get the sum of the coefficients. Very, very important concept. Sum of the coefficients can be determined by keeping 1 in place of every variable. By keeping 1 in place of every variable, I will get the sum of the coefficients. I will get the sum of the coefficients. I hope this idea it is clear. Right, we will only discuss the fundas today. So sum of the coefficients, C0 or NC0, both are same way of writing. C1 means NC1, C2 means NC2, Cn is NC2. I hope the idea it is clear. NC0 plus NC1 plus NC2 and so on up to NCN. I'll give another very interesting way of looking at the proof from a Venn diagram point of view. From a Venn diagram point of view. One minute. I will take a new slide and I will tell you another way of looking at it. See here. Suppose there are two sets are there. Why it is 2 power n? Suppose there are two sets are there. There are 3 sets are there. There are 4 sets are there. 2 sets, 3 sets, 4 sets. Now if you see here, another way of understanding why it is 2 power n. So there is a set of students who like cricket. There is a set of students who like football. There is a set of students who do not like any. Who do not like any. Mu represents the total number of students in the class. Mu represents the total number of students in the class. Now listen carefully, sir. Listen carefully. This contains 4 regions. These are the students who do not like any sport, whether it is cricket or anything. These are the students who like only one sport, that is cricket. These are the students who like only one sport, that is football. These are the students who like football and cricket. Totally, how many are there? Totally I got 4 regions I got. Totally I got 4 regions. Totally I got 4 regions. I hope it is clear. What are that 4 regions? 4 regions is, one is none region, only one region, and 2. None plus only 1 plus 2. Are you all with me? So same is the case here. Suppose if n equivalent to 2. If n equivalent to 2. There are 2 sets are there. From 2, I do not like any sports. 2C0. From 2, I like only one sport, whether it is cricket or football. From 2 sports, I like all the 2 sports. 2C0 plus 2C1 plus 2C2, which is nothing but 2 square. Totally how many regions we got? 4 regions we got. Out of 2 sports, I did not like any sport. Out of 2 sports, I liked one sport. Out of 2 sports, I liked 2 sports. So 2C0 plus 2C1 plus 2C2, which is equivalent to totally how many regions? 2 square regions. Similarly, for 3 sets, there are students who like Hindi movies. There are students who like regional movies. There are students who like English movies. English movies. Listen carefully, sir. There are students who like English movies. Totally how many regions are there? 1, 2, 3, 4, 5, 6, 7 and outside it is 8. Totally 8 regions are there. 3 sets I got 8, which is 2 cube, which is 2 cube. 2 sets I got 4 regions, which is 2 square. So let us see whether it is, we got 2 cube. Let us analyze one by one. From where we got these 2 cube? Out of 3, I do not watch any movies, which is 3C0. Out of 3, I do not watch any movies. It is only one case, 3C0. Out of 3, Hindi movies, regional movies and English movies, I like only one type, 3C1. NC1 it is 3. 3 regions are there. This is only Hindi. This is only regional. 3 only regional movies. Only English movies. Only English movies. 3 cases. Out of 3 kinds of watching, I watch any 2. Any 2 is, this is H comma R, this is R comma E, this is H comma E. Out of 3, I watch all 3 movies, 3C3. This is HRE. I hope the idea it is clear. 2 power 3. Totally 8 regions I got. Out of 3 kinds of parameters given, I do not watch any movies. 3C0. I got 1. Out of 3, I can watch only Hindi or only regional or only English. 3C1. 3 regions. Out of 3, it is 2. Out of 3, it is 3. I hope it is clear. For 2 sets, number of regions are 2 square because of this concept. NC0 plus NC1 plus NE2. Sum of the coefficients is given by 2 power n. Sum of the coefficients. Suppose if it is 4 sets. Let me draw 2 sets horizontally. 2 sets vertically. 2 sets vertically. Then we will understand the problem. 2 sets horizontally and 2 sets vertically. Listen carefully. Listen carefully. Totally how many regions are there? Let us see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. This portion it is 20. I hope it is clear. But according to this definition, 2 power 4, 16 regions I should get. 16 regions I should get. Now listen carefully. Listen very carefully. Suppose if it is A, this is B, this is C, this is D. What is this region, sir? What is this region? Only C. What is this region? Only C. What is this region? Only D. What is this region? Only D. What is this region? C and D. What is this region? C and D. 3 are duplicated. Similarly, what is this region? Only A. What is this region? Only A. These only B. This is only B. A intersection B, A intersection B. That means bottom 3 are duplicated with the top, which I will call it as an water image. If I keep a mirror, these 3 are also an mirror images of these 3. That is the reason if you keep 2 circles horizontally, 2 circles vertically, it looks like 22 regions are there, out of which 6 are duplicated. The bottom 3 is the water image of top 3. Right hand side 3 is the mirror image of left hand side 3. This is water image, remove it. This is either you remove this portion or whatever the portion. I hope the idea it is clear. Anyway, in set theory, Venn diagrams I will discuss in detail. Idea is to tell you NC0 plus NC1 plus NC2 and so are NCR. It is given by 2 power r. I just wanted to tell you from an set theory perspective. Number of terms, I hope it is clear. So we are discussing sum of the coefficients is given by 2 power n. Sum of the coefficients it is given by 2 power n. Suppose if I want alternatively plus and minus, same thing, you take x plus y power n, put x equivalent to 1, y equivalent to minus 1, then you will realize that it will be equivalent to 0. Sum of the coefficients is given by 2 power n, alternatively plus and minus it is given by 0. If I add these both will get cancelled. 2 into C0 plus C2 and so on. So 2 into C power 0, C2, NC2, NC4. It is 2 power n. So answer is 2 power n minus 1. Sum of the even coefficients is given by 2 power n minus 1. Sum of the even coefficients is given by 2 power n minus 1. Similarly, even if you subtract C0 will get, sum of the odd coefficients is also given by 2 power n minus 1. Total sum of the coefficients is given by 2 power n. Sum of the even coefficients is given by 2 power n minus 1. Sum of the odd coefficients is given by again 2 power n minus 1. I hope the idea it is very, very clear. Again, the proofs of these important key terms, it is clear to you. If the power is n, why it is n plus 1? I hope it is clear. So the generic term of the expansion, out of n, I am not selecting any power of y power 0, so remaining x power 1. Out of n, I am selecting 1 power of y, remaining n minus 1 is given to x. Out of n, I am selecting k for y power k, remaining it is n minus k. The power of x is decreasing by 1. Power of y is increasing by 1. This is an observation. Power of y is increasing by 1. I hope this key point it is clear. What is a binomial? Binomial is a polynomial with 2 terms. First important key point. Second important key point. In x plus y power n, if the power is n, number of terms will be n plus 1. Then how to find out the number of terms beyond polynomial? We discussed with respect to a non-negative integral solutions. Then we expanded it to a polynomial with 10 variables, 12 variables, 13 variables. Y NC0 it is 1. Y NCn it is 1. Selecting n is rejecting 0. Selecting 1 is rejecting n minus 1. Selecting k is rejecting n minus k. Sum of the coefficients is given by 2 power n. Sum of the even coefficients is given by 2 power n minus 1. Odd coefficients is given by 2 power n minus 1. Now another important point, because it is, if it is n, totally how many terms will be there? N plus 1 terms will be there. Totally n plus 1 terms will be there. First term it will start with 0. Second term NC0, NC1 and so on. So the nth term is given by the expansion. This is very, very important. Nth term is given by the expansion. NCR, x power n minus r, y power r. Out of n, I am selecting r for y. Y power r, remaining n minus r is given to x. Very, very important. The generic term is given by, out of n, I am selecting r, y power r, x power n minus r. Why it is becoming r plus 1? Because the first term it is starting from 0. So NC0, to get 0, NC0 will become first term. So r is 0. Second term NC1 1, NC1, NC1, NC2, NC3. So second term means R value will be 1. That is the reason it is R plus 1. We will not use any of these formulae. We will try to solve it very logically. We will try to solve it very logically. I hope all these concepts are clear to you. 2 sets, 3 sets. So from tomorrow, a lot of very, very good problems we are solving. Tomorrow's class, do not miss it, sir. 14th term, how to find out the 14th term. Term from the end. How to find out the power if terms are there. How to find out the constant term. How to find out the independent term, how to find out a coefficient of x power r, how to find out the greatest term, numerically greatest term, how to find out the sum of the coefficients, how to find out the number of integral terms, how to find out the number of rational terms, how to find out the power, greatest integer function, related problems, greatest integer, some miscellaneous related problems with a condition. How many terms will have odd coefficient? Definition of a multinomial theorem. How to find out the coefficient? How to find out the number of terms? Distinct terms. If the number of terms are given, how to find out the terms if there is a plus and minus sign? How to find out the positive terms? How to find out the negative terms? How to find out the coefficient of the expansion? How to find out beyond a binomial, how to find out the coefficients for a beyond a polynomial expansion? Polynomial. This is the kind of question I just discussed. A plus B plus C. Tomorrow, these are all the questions which we are going to discuss tomorrow. These are all the questions. All the questions which we are going to discuss tomorrow. Binomial theorem. As I told you, I will schedule the classes, all the classes, whatever we did it. I think by tomorrow morning you should see it in the portal, right? So tomorrow don't miss the classes. 3 to 4 classes I will take and I'll solve every possible concept in binomial theorem. Thanks a lot for attending a lot of marathon classes today. Hope to continue the same rhythm till the CAT examination. Thanks a lot. With love, Anil Nair. We will catch up tomorrow at 1 o'clock. Thank you.